Right. Coming to the next topic, nomenclature of organic compounds. This is one of the very important concept in the chapter carbon and its compounds. Carbon and its compounds, because of we need to give a name for the particular organic compound, for a particular organic compound. So by following certain rules set by IUPAC, International Union of Pure and Applied Chemistry, International Union of Pure and Applied Chemistry, right? So we have so many organic compounds, we have so many chemical compounds. So to remember those names, individually, very difficult because of we have many organic compounds. To remember those names individually, it is so difficult task. So to overcome this problem, they have to properly name. We need to give name. Why should we are all the human beings, but we have different kinds of names. For easy identification. Similarly, due to the millions of organic compounds, to remember those names, we need to give one to identify the organic compound, we need to give a name. So these names are given by IUPAC, International Union of Pure and Applied Chemistry. So is taking a responsible to name the organic and inorganic compounds in a systematic order. The basic idea behind the systematic nomenclature is that there should be only one name for the given section throughout the world, and also there should be only one section for the given name. So throughout the world we need to use only one name for different kinds of organic compounds. The same organic compound has two or more different names. So in different places they call different names. So to avoid such a problem, IUPAC is taking the responsibility to give a common name for the organic compounds. And inorganic compounds. So IUPAC, the IUPAC, we can call IUPAC name of an organic compound consists of mainly three parts. What are those parts? Let us take some introduction. So IUPAC name consists of three parts. One is word root. So word root means number of carbon atoms present in the compound. A organic compound contains some number of carbon atoms. So that number of carbon atoms you can taken as the word root. Then, so one carbon atom, 2, 3, 4, 5 like that. So the number of carbon atom present in the organic compound you can taken as the word root. Then coming to the next one, prefix. This prefix explains about the substituents. The organic compound contain any substituents are shown as the prefix. Any substituents. These substituents are four types, means four categories. One is primary prefix, secondary prefix, numerical prefix, number prefix. primary prefix, secondary prefix, numerical prefix, number prefix. Primary prefix. This primary prefix is used only for cyclic hydrocarbons or cyclic organic compounds. So what we discussed in the previous session. So the primary prefix is used only for cyclic compounds and ringed compounds or closed compounds. Closed compounds. Then coming to the secondary prefix. Functional groups as substituents like halo, alkyl, oleic acid, alcohol, etc. If any organic compound has functional groups, we discussed many functional groups in the previous sessions. So like alkyl, halo, alcohols, acetic, oleic acids, ketones, aldehydes, anilines, amides, ketones, etc. So if any organic compound has such functional groups, to be taken as a secondary prefix. Then numerical prefix. Same substituents or multiple bonds or functional group is repeated twice, thrice, like that. The same functional group repeated means the same functional group or the substituent repeated again and again. So just for example, I am making 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So how many carbons are there? 5 carbons. So wood root, 5 carbons. Then cyclobrom, secondary prefix. Functional groups as substituents like halo, alkyl, acid. For example, if taken, this carbon has a functional group OH. This carbon also has OH. So same substituent or multi-group bond, means double bond or triple bond or functional group is repeated twice, thrice. For example, if you take one more carbon, if this also has OH, so how many functional groups are there? 3 functional. Same functional group or different functional group? Same functional group, alcohol. So alcoholic hydroxy functional group as substituent in the given compound repeatedly. So 1, 2, 3. How many times repeated or it is substituted in the compound? 3 times. So repeated twice, thrice. We can write them di, tri, tetra, pent, hex, like that. So that how many substituents are attached to the carbon or connected or bonded with the carbon atoms, then we can take it as numerical prefix. Then number prefix. For which carbon atom the substituents are? For which carbon atom to the compound has substituents are attached? For which carbon atom? First carbon, second carbon, third carbon, fourth carbon, like that. For example, if we consider this 1, 2, 3, 4, 5, 6. For which carbon atoms hydroxy groups are substituted? For second carbon, for third carbon, then fourth carbon. So for which carbon atom has the functional group, we can represent with the number prefix. Numerical prefix. how many, same or substituted. Number prefix for which carbon, the substituents are substituted, like functional groups are double bonds are, triple bonds are, like that. Then the third part of the name of organic compound is suffix. So suffix is functional groups in the compounds. Right? So prefix means secondary prefix means if the functional groups are as a substituents. Then what about functional groups in the compounds? For example, you can take in CH3, CH2, CH2, CHO. CH3, CH2, CH2, CHO. CHO and aldehyde. Aldehyde. So this is a single compound only. This is an organic compound. This CHO is a functional group, but this CHO is not a substituent. If this is, or if we consider the same example, for example, OH, alcohol group is there. Here OH, here also OH. This is the main compound. For main compound, we have 3 functional groups with same hydroxy functional groups to the carbon atoms. But here, this is a functional group. This functional group is not a substituent. This functional group is not a substituent. This functional group is the part of compound. It is the part of compound. If the functional group is substituent, then we can call as prefix. If the functional group is a part of main compound, then we can call as a suffix. So this is difference between prefix and suffix. For example, if we attend any function, we are the guest. If we attend the function, we are the guest. If the function is ours, we are not the guest. We are the main person in the function or any festival. So if the function is happening in our home, we are the main part. The function is happening because of we are the main one. If we attend any other functions like friends, relatives, we are not a main part of the function, but we are the guest only. So functional groups are as substituents. You can take it as a prefix. If the functional group is the part of main compound, then it is a suffix. Then 3 types. One is primary suffix. Saturated or unsaturated. Saturated compounds or unsaturated compounds. Double bond or triple bond. If it is a single bond, saturated means A. You can write A, alkane. Unsaturated 2. Double bonds, triple bonds. E I. E I. So then secondary suffix. Functional groups with a particular term. Functional groups with a particular term. For hydrocarbons, the hydrocarbon, the name of the hydrocarbon is end with. The particular hydrocarbon end with E. Alkane, alkene, alkyne. So end with E for hydrocarbons, either saturated or unsaturated. So for alkane, A. For alkene, E. For alkyne, E. So end with E. Hydrocarbon end with E. If it is saturated or unsaturated, then we are given the name. For alcohols, for alcohol, OH, you can name it as a particular term, ol. For aldehydes, all. For carboxylic acid, oleic acid. For ketone, C double bond O, you can write O. So 1, 2, 3. 3 carbons. 3 carbons, you need to write prop. Which functional group we have? Hydroxy, nothing but alcohol. Nothing but alcohol. Propanol. So alcohol is ol because of it is the part in the main compound. It is part of the main compound. But here OH group is a substituted guest. So 1, 2, 3, 4, 5, 6, 6 carbon atoms are there. All single bond. Hexane. So how many OH groups are there? 3. Right? 3 means you can write tri. For which carbons has second, third, fourth. So 2, 3, 4 triol hexane. Its name is 2, 3, 4 triol hexane. Because this OH group is not a part of main compound, but this OH group is a main part of the compound. Then one more is number suffix. Number suffix also there. Number suffix. So number suffix as usual for which atom consists of the functional groups or saturation or unsaturation. Saturation, unsaturation. Number suffix. And even it is also has a numerical suffix. Numerical suffix and already we discussed how many are there functional groups. How many functional groups are there? Then for which carbon atom they have. Sometimes a compound has another functional group also. Two functional groups are there. Here this is the main part, this is the substitution. Based on that secondary suffixes, then we will give the names by following some rules. But while giving priority, giving name for the organic compound, the priorities are, let's see, prefix. See the table, prefix, old root, suffix. Prefix, old root, suffix. So first priority means in the given for giving name for the particular compound, first of all we need to write any prefixes. Prefixes means these. What? Primary prefix are secondary prefix, numerical prefix, number prefix. Then, so if the compound has halo compounds, halo elements like fluorine, chlorine, bromine, iodine, etc., or alkyl groups, CH3, C2H5, C2H7 like cyclo. If it is cyclic compound, cyclo is if it is a cyclic compound, you can write as cyclo. For example, you can take like CH3, CH2, Cl. Right? How many carbons? 2 carbons. 2 carbons and then 10. So substitute them here. Prefix is there. Right? Chloro. So first you can write chloro. The substituent functional groups like alkyl hydroxy, oleic acid, keto, aldehyde, amines, esters, whatever. Chloro. Then wood root. So how many carbons? 2. 1, 2. 2 in the eth. Between the carbon and carbon, single carbon bond or double bond or triple bond. Double, single bond only. Single bond we can write ethane. Its name is chloroethane. If it is cyclic compound, how many are there? 3. So CH2. So cyclic compound. So first priority is primary suffix cyclo. How many carbons? 3 carbons. 3 carbons which is pro. Between carbon and carbon, not a single bond is there. So a cyclopropane. Here cyclo is prefix, pro word root, a suffix. So every every organic compound has 3 parts. One is word root, prefix, suffix. While writing a name for the organic compound, first part is prefix. Then the middle part is word root. And the third part is suffix. Based on substituents, based on functional groups, based on saturation, based on unsaturation, then we have to give the names for the organic compounds. Right? So keep in mind this is we didn't discuss any rules. Just we are taking what part the parts of name. The name consists the organic compound has 3 parts. One is word root, prefix, suffix. Right? First you can write prefix, then you can middle part is word root, then the third part is suffix. Then it is primary suffix, secondary suffix, numerical suffix, number prefix or numerical prefix. Similar suffixes also. Primary suffix, secondary suffix, numerical suffix, number suffix. Right? So these are introduction about nomenclature of organic compounds. Right? So please watch these videos frequently for understanding how we have to give the names. So during the examination also there is a possible to ask write the name of the given compound and write the structure. Maybe it is maybe asked, right? So these are some points regarding to nomenclature of organic compounds. IUPAC or IUPAC, International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Then we will discuss rules. After the rules, then we need to write names. Before that, we will take a few examples. Then we need to follow some order. So what is that order? Prefix, word root, suffix. Prefix, word root, suffix. Or numbers. Numerical prefix, secondary prefix, primary prefix. Then we will discuss now. Now we are going to discuss the order. Now we will discuss some order for writing a name for the organic compound. Just follow that table. Based on the table, then we can give it the prioritize. So organic compound must consist of the order. How we can write the order? Numbers. First. Then we can write numerical prefix. Second. Then number prefix. Then secondary. Numerical secondary. So maybe it is so confusing, you need to get. So better we have to give the priority first for prefix, word root, suffix. If I write like this, it is very difficulty for you understanding, because of here different kinds of numbers are given. Numerical, secondary prefix. Here secondary prefix, then primary prefix, word root, then you can write again numbers, numerical prefix. So numerical prefix 3, 4, 5, 6, 7. Then After we can write primary suffix. It is then say order is 8. Then numbers. Then numbers. Then numerical prefixes. Numerical prefix is 9 and 10. And secondary suffix. Secondary suffix. This is the order. This is the order. So, what differences we have to find among 1, 2, 3, 6, 7, 8, 9, 10? 1, 2, 3 and 6, 7, 8, 6, 7, 8 and 9, 10, 11. 9, 10, 11. What the difference we have to find? 1, 2 are numbers and numerical designations to be written for secondary prefixes. 1, 2 are numbers and numerical designations to be written for secondary prefixes. Secondary prefixes. What is secondary prefixes? Substituents. Substituents. Functional groups are halo, like functional groups. How many functional groups are? How many functional groups are substituted? For which carbon atoms they are substituted? Which tells about the position and repetitions of second grade functional groups known as substituents respectively. Substituents respectively. So, these 1 and 2 are substituents. Means these two are related to the secondary suffix. Means secondary functional groups as substituents. Substituents. These two are related to this. For example, CH3, CH2, CH2, CH3. This is 1, 2, 3, 4 carbon atoms. Then here we can write chlorine. Here also we can write chlorine. Chlorine nothing but halo. Halo groups are. How many are there? 2. How many numerical suffixes? If 2 means we can write di. For which carbon atoms they are substituted? If it is considered 1, 2, 3, 4, then 1, 2, 3, 4. So from left to right to left, if we count the carbon atom, same. 2, 3. This 2, 3 is nothing but numbers. This die is nothing but numerical prefix. What is the secondary prefix here? Chloro. That is the meaning. Right. Next. 6 and 7 tells about the position and repetition of the multiple bonds. Okay. Then this is first part. So primary prefix is there anyone? This primary prefix about the cyclic compounds. No cycle, no ring structures. No ring structures. So no need to take it as consideration. No consideration for this. After that, what we have? Word root. After that, what we have? Word root. So how many carbons? 1, 2, 3, 4. 4 bute. Bute. Between. After that, again 6, 7. 6, 7. This 6 and 7. This 6 and 7 tells about the positions and repetitions of the multiple bonds in the structure of the molecule of the compound. These are related to the primary suffix that tells about unsaturation. These 6 and 7, this 6 and 7 is related to primary suffix. Primary suffix, that primary suffix tells us unsaturation. Unsaturation. Double bond or triple bond there or not. See, in the given compound, is there any double bond or triple bond? No, only single bond. So, after that, word root, then we can write the 11th part, secondary suffix. Secondary suffix. Secondary suffix tells about, suffixes are tells about saturation, single bond, double bond or triple bond. So this compound has only single bond, bute plus A. Bute plus A. So the name of the compound is 2,3 dichloro butane. Butane. 2,3 dichloro butane plus E. Plus E. So now we can write here 2,3 in the sense first part. 2,3 in the sense first numbers. This is the first part. This means this di means second part. Second part, numerical prefix. Numerical prefix. Chloro, secondary prefix. Bute, bute, even the unsaturation. Primary suffix and saturation and unsaturation. 8. Single bonds. Single bonds. Bute. Bute means 5. Here 5. Here 5. Word root. This is word root. And single bonds. 8. Finally E. This is 11th part. This is 11th part. So like that we have to give the names. Give the names. Right. Then 6 and 7 tells about the position and the repetition of the any multiple bonds, like if the compound has double bond or triple bond, then how many double bonds or how many triple bonds are there? For which carbons having double bond and triple bond. For example, you can take CH3CH double bond CH triple bond CH. unsaturation ekkada here and here, here and here, right? How many carbons in that? First of all, 1 2 3 4 5, 5 and there was some 5 is wood root, pent, pent, right? Then 3 means which carbon has double bond, which carbon has a double bond. Count 1 2 3 4 5, here priority 1 2 3 4 5. So 3 in for third carbon having double bond, so in. Then first one ion, first carbon has triple bond, one ion, ion, ion. So pent 3 in one ion, one ion. So here this 6 and 7, this 6 and 7 numbers related to primary suffix. If any compound has unsaturation, either double bond or the triple bond, how many double bonds are there, how many triple bonds are there, for which carbons have the which carbon has first carbon, second carbon, third carbon or fourth carbon has saturation, you can write like this. Then 9 and 10 tell about position and repetition of the functional group or principal functional group in a polyfunctional compound, in a polyfunctional compound. These 9 and 10, this 9 and 10 explains about the secondary suffix, nothing but functional groups, nothing but functional groups. Means two or more functional groups are there. If a organic compound has two or more functional groups, how many functional groups are there, for which carbon atoms they are attached or they are connected, we can explain with 9 and 10. Explain with 9 and 10. For example, CH3, CH2, 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 OH. Here we can take OH. Okay. How many carbons? 1, 2, 3, 4, 5. 5 carbons. How many functional groups? What is the functional group present here? OH. Here also OH. So this OH is the main part of compound. Main part of the compound. This OH is the substituent. This OH is the substituent. Substituent means secondary prefix. How many functional groups are there? 2. How many functional groups are there? 2 and numerical prefix. Numerical prefix you can write di. For which carbons they are connected? 1, 2, 3. So 1 to first carbon, third carbon. First carbon and third carbon. Main OH, all. All. 1, 2, 3, 4, 5. Pentanol. So 1,3 dipentanol is name. Butane 1,2-diol or butane 1,2-diol. So sorry. This start concept. 1, 2, 3. Okay, 5. 1, 2, 3, 4, 5. So 5 and pent. It has 5. Can write pent. Then for which carbons it has 1, 3. 1, 3. How many functional groups? 2. 2 in the sense di. What is the functional group name? 4. Pent 1, 3 diol. Pent 1, 3 diol. Pent 1, 3 diol. So here this first OH, this OH is in the part of compound. This OH is a substituent. This OH is a substituent. Then, so what we discussed? The first 1 and 2. 1 and 2 are related to the secondary prefixes. Then 6 and 7 are related to the number 8, nothing but the unsaturated. Double bonds or triple bonds are there between the carbon and the carbon atoms in the compound. Then this 9 and 10. This 9 and 10 are related to secondary suffix. Means if 2 or more functional groups are there in the organic compound, then how many functional groups are there? For which carbon atoms they are substituted? Which carbon atoms they have? Right? Then word root atoms. This primary prefix only for cyclic compounds, cyclo compounds, cyclic compounds. Whatever first the priority is prefix, word root, suffix, and functions and functionation. So we can give the functionation. Numbers are separated by comma. Numbers are separated by comma. Means number prefix, number suffix. Number prefix and number suffixes are separated by comma. So in this compound, for second carbon, third carbon has chlorine as a substituent. So 2, 3. 2, 3 means second carbon, third carbon has substituents. So that are separated with comma. That means for which carbon atom the substituents are there, for which carbon atom the unsaturation is there. That number of carbons means first, second, third, fourth, fifth, like that. Between the carbon atoms you can write comma. And numbers and designations by hyphen. Numbers are designated by hyphen. Means after this we need to give one hyphen. So means a hyphen between number prefixes, number suffixes, and numerical prefixes, numerical suffixes. Numerical suffixes. Right. If you find more than one substituent in the structure, you have to follow alphabetical order naming them. For this, numerical prefixes should be numerical prefixes not considered. Substituents X, halo, or alkyl, or alkoxy, OH, hydroxy, CHO, all, like that. If you find more than one functional group in the structure, you select the principal functional group and write it as secondary suffix. All other functional groups become substituents. We already discussed. If this compound has more than one functional groups, so the functional group which is connected, which is attached to the main compound, taken as secondary taken as substituents. This is the main chain. This is the substitution. And we need to give the priority for the secondary functional groups. The first priority for the secondary functional groups, OIC acid, first priority. Second priority, aldehydes. Third priority, ketones. Fourth priority, alcohols. For example, if it is as like this, COOH, and we have OH also. COOH, OH both are there, but the first priority goes to carboxylic acid. The first priority goes to carboxylic acid. Carboxylic acid, COOH. Then after, give the priority OH. So this is the decreasing priority. First priority is COOH. Third one is, second one is CHO. Then CO, OH, like that we need to write. So these are some points which are related to nomenclature. Then next we will discuss principles.